Okay, so on the board, first of all, often it's drawn like this, right? Here's the nucleus of the atom, the first energy level, second, third, fourth, a bazillion others until you get to the infinite energy level where the electron gets kicked out of the atom entirely, right? Photoelectric effect. All right. Think of it this way, right? Because the photon is going to come in and collide with the atom, the electron, and it's going to add energy to it. And yet, when it's totally the minimum amount of energy kicks it out of the right, the minimum amount of energy kicks it out of the atom, but has no extra kinetic energy, right? So if it's out of the atom, it has no potential. And if it has no kinetic, it has zero energy. So that infinite point has zero energy, zero electron volts, which means if you're adding energy to get to zero, we need a negative amount of energy at a given energy level to get to zero. Does that make sense? So often it's presented in a way that the closer to the nucleus, the more negative energy, has negative potential energy. The electron does, right? All right, so next, the thing that I feel like I screwed up on or didn't talk about it and present it accurately enough is when that photon comes in and collides with the electron, right? We've talked about how there's specific amounts of energy at each energy level. In order to move the electron, it needs that specific amount of energy in the photon. So for example, I made up a little thing that you have -10 electron volts at energy level 1, -6 electron volts at energy level 2, -3 at energy level 3. If this incoming photon has 4 electron volts worth of energy, it can bump the electron from -10 to -6, right? That's simple enough, right? It can do that. If this has 4, it can bump it there. If it has 7 electron volts, it could bump it to there and end up there, right? That makes sense? That's simple. What happens if it has 5 electron volts? What happens to the electron? All right, so logic would say, well, that's enough to get to the second level and has a little extra, right? But what happens is nothing actually ends up happening. The electron does not move energy levels unless it has the incoming photon can pass on the exact amount of energy it needs. So this incoming photon, if it had 5, it would not move the electron. Okay? That energy would just continue to pass on through the atom. That energy would continue to pass on through the atom. That wave, that photon would continue to go on through the atom. Right? If you remember, we talked about the absorption spectrum and the emission spectrum, right? The absorption spectrum, right, was Roy G. Biv, right? You had the violet over here, and you had the red over here. And in there were these black lines somewhere, right? The black lines. But the rest, you could see the spectrum. You remember that picture? Well, this black line, making up a number, right? I guess starting at the lower energy. This black line is the 4 electron volts of energy that got absorbed. But the 5 electron volts of energy we can still see. The 7 electron volts of energy gets absorbed because that wave is used to excite the electron. 7.5, 8, 8.5 up to, well, 8.5 is my next one, right? 7.5 up to 8.5 is the next one. It's absorbed, it's black on the spectrum, right? And so on until you get to anything. So the 10 electron volts gets you out. Anything more than 10 electron volts though is good too, because now it's out plus kinetic energy, right? But it's the from zero of the incoming to the whatever to get to the next energy level. It needs the exact amount, or else the electron does not move to the next level. Okay. And the exact opposite happens if the electron starts as excited and it drops in energy level. It gives off that amount of energy, that wave. So the emission spectrum, that's what I mean, the emission spectrum is the exact opposite of the absorption spectrum, because when the electron goes that way, right, and it goes from a higher potential to a lower potential, it gives away that amount of energy in a wave. And then that shows up on the emission spectrum. So everything is clear except for boom, that one color, right? And as it drops, it doesn't have to drop all the way to the ground state in one shot. So if the electron is here, it could drop all the way. It could drop all the way and give off one color in one wave, or it could drop in 2 stages. Drop to here, give off a wave, and then drop to there and give off another wave, right? But it's always very specific amounts of energy. Okay. Is that better? I feel like I did a better job with it today than I did yesterday. I'm hoping I did. Right, but that's a pretty important concept. It's a very important concept, I should say. Okay. You're going to see questions. I'm willing to bet that you will definitely see questions about absorption spectrums and emission spectrums and changing energy levels and the energy involved in that. Okay. Does anyone have any questions on that? I felt like that was a key thing that I screwed up or did poorly yesterday, that once I reread and did a little more research and stuff. Any questions on anything? Okay, that was the only one thing I wanted to cover again. So I'm going to stop the recording because I'm not going to teach anything new in addition to